week 4. I kind of switched, went ahead, go in sequence. So far we did primary by itself. We did Aquastat and primary. That's an integrated system. Yes, this week we are doing 2 zones, which is primary, Aquastat, and switching relay. Okay? So next week, Lance and Brody, can you please keep it going? This time we'll do 2 zones. I mean, more than 2 and 3 zones using switching relay. That is a board, like Teku board, with primary and so we're going to use the primary control, Aquastat, and switching board. So this can enable you to have more than 2 zones, 1, 2, and 3. Guys, come on. So far we've been doing this in pairs. I want you to do at the end, like 2 weeks from now, I'm going to have you do it individually. So make sure you understand what's happening, and hopefully at the end you'll be able to do it in less than an hour with least confusion. So pay attention. We did it in pairs for like 3 times. We're going to do it for 4 times. So hopefully the 5th time you'll be able to do it alone with no problems.
I was going to say, next week are we going to use that?
Yeah. So please pay attention. Have the graphs with you, and try to know which wire goes where. And hopefully by now we develop the sense of what's happening. So I'm going to add one usually as a repetition, just to make sure that we do the wiring correctly on the board. On the board it's a little bit easier than doing it on the burner. You'll find it the other way around. When you go to the boiler, you find it much easier because you already did it on the board when everything is in front of you. And again, on the boiler or the furnace, it's going to be a little bit iffy because you're going to have actual oil going inside, an actual flame. So I would like to know that you've got things correctly first before we can go and practice on live boilers or burners. Okay? So this time we did 2 zones. This week we're doing 2 zones using a switching relay. Next week we'll use take a switching relay, which can operate either zone valves or pumps. So either you can have more than 1 pump, or we can have either more than 1 zone valve. It's different board, so make sure you buy the right board, because how many volts the zone valve takes? 24, and a pump is 120. So if you mix that up, it's not going to work the same way. So we'll do take a control system. Hopefully by now there are no problem with wiring a primary, and so far I've seen good results. Everybody's comfortable with it? Why are you looking at me like that? Thank you. Should be easy. Black goes to L1. Limit goes to either Aquastat. If you have Aquastat, if there is no Aquastat, it has to be getting power, otherwise it's not going to go on. We know how to wire the CAD cell and the TT. Get jumper. The system is integrated. Otherwise, TT will have to connect to a thermostat. So hopefully by then, this is not going to be, I think by now this is not going to be a problem, right? The Aquastat you did it only once. You're going to do it again this week, and you're going to do it again next week. So again, repetition makes things a little bit better. You have noticed that there's some kind of struggle with putting the wires on the terminals. If you go clockwise, it's easy to put them in there. There's a box full of spade connectors. Use spade connectors and connect the wire to it with the wire nut. That's a very easy way to do. So spade connectors are very easy and convenient. Make things convenient for you. Also try to use the hub or the common. Otherwise you're going to end up with a bundle full of neutrals, which is not going to stick correctly, and it's not good practice in real life. I don't want to see that. Please have a really good connection. And if you look actually behind the primary, there's a lot of terminals for neutrals. So in real life, use those terminals to reduce the bundles of wires you want to put together. Because if you notice, after a while they don't really stick together correctly, and they're going to get loose. If they get loose, you'll get a short. It's not going to work. Okay? Aquastat is the old one. We have a couple of the old ones on the boards, and we did see it function. A couple of times actually we had issues with the neutral. You'll get power, it will work, one of the components don't have neutral. So it's a good practice to go and check your wiring and make sure all the circuit is completed. So next week we will wire a zone valve. This is one of them. I think this one does zone valve, not pumps. So if you have a zone valve, you're gonna use a light bulb for the zone valve. It's gonna light very dimly because the light bulb is rated for 120, and you're giving it 24 volts. Let's show you if it's on and off. There are two boards that have actual zone valves on them. You can use those, and you can see that it's on and off. So we'll check that out. So this one has 4 zone valves. For our boards, we only have 2 thermostats, so we're just gonna use 2. But you know, if you're gonna add zones to it, it's gonna be more thermostat and more zone valve at the same switchboard. It's very convenient. These boards are not cheap, so make sure you don't have a problem connecting them. The back is metallic, so make sure there's nothing in the back that sticks a short circuit. This circuit operates on 24 volts, that's why we have our transformer here. These are the zone valves. They are rated based on the size of the pipe, and the direction is always fixed. So make sure you put it in the right direction of the water. Do not put it the other way around. There are a lot of zone valves where the valve itself does not go bad, only the solenoid valve, so you can twist this and take it out and change it. It makes things a little bit easier, and they are quite expensive. So make sure when you change one, you do it properly. Like they range from $75 to $300. Again, they have a lot of reliability and testing, so they like to have them last for a long time, but they do go bad at some point. Some of them connect directly to the thermostat, they open and close. Some of them require to have a zone valve control. So check the instruction before you buy a zone valve. This is the board. If you see now, the schematic gets really simplified. So if you look here, that is your aquastat. See how it gets very much smaller? They assume it's already connected, but they give you all the terminals. So we did use the ZC and ZR, right? Before, with switching relays. Now the ZR and ZC are going to ZR and ZC, H and H here, and this is a jump, so it's not connected, and the dots are connection. And what is this here?
Can't really read it.
If it's connected to B1 and B2.
Burner relay?
Yeah, that's the primary relay, primary control. So they're not telling you how to connect your primary because they're concerned mainly with their own board. And this is your aquastat and thermostat here. And this is for one zone. And these are all our switches that we saw on the board.
So the switching relay powers the Honeywell, is that correct?
Say that again?
The switching relay powers the Honeywell with the 120 volt?
No, no. This gets its own power line. See? It's getting its own power line by itself.
With the 120 volts
From the board, yeah.
From
So
the
if-
zone?
If you look here, this is a hot line 120.
Right,
One is going to the hot in the board, and one is going to the aquastat.
right, and then there's 120 coming out. So so what powers, so what's the 120 volts AC with the ZC and the ZR, the ZR?
Yeah, that's the connection from the aquastat to the switchboard.
And that's 120 volts?
Yeah.
And that's
those
coming
two-
from the Honeywell?
Yeah, you can see that here. You can see the connection here.
That's not in the Honeywell, or is that in that controller?
This is an aquastat.
Okay,
Follow the connection. ZR. Follow the ZC. Here.
so that's just the drawing of an aquastat, that's not inside the 4-zone switching relay. That's not inside the green, it's not in there, is it?
But this is inside the green box.
But the other one isn't?
No.
Oh, okay.
So this is the green box.
Okay,
This is an aquastat.
that's aquastat, okay.
Looks intimidating.
No, I was just curious,
Yeah.
trying to ask the question in a different way.
And we said this is the primary control?
Primary, right, negative and neutral and high.
No, they're not giving you the whole connection because they assume you already connected that.
So that,
This is this.
Yeah.
You're gonna wire it the same way, motor, valves, and
The limit
limits.
goes to B one.
Yeah.
so question, that,
And this is this.
Yeah.
that 120 VAC from the ZR to ZC, coming from the Aquastat, does that go to a transformer to power the board that does the zone
Yeah,
bells?
yeah.
And then the other 120 is another
It's for control.
transformer to do the rest of it?
Now, this has its own connection. It tells the switching relay to turn on based on the heat in here. So it's a control, but it's also 120 coming from the ZR and ZC in this board.
Okay.
So you have 220 coming in. This is to power the board, and this is to control the board.
Oh, okay.
Good?
Yes.
And again, each one of those boards
Can you go?
is wired differently.
Are there two thermostats or not? One on the,
So we have one zone being controlled by the Aquastat.
what is another thermostat?
This is one zone here, controlled by the switching board. You can add zone 2, 3, and 4 if you want to, but he's giving an example of one.
So which thermostat is coming from, the one on our wall? Is that the one going into
The room,
Aquastat?
the room thermos?
Yeah, or is it going to the, that's going to the Aquastat, right?
Yeah.
Okay, that's what controls everything.
Basically, we should have two thermostats because it's two zones.
Yeah.
One is Aquastat and other is like.
Otherwise, there's no
Take-
point to the whole thing, you know?
So the Aquastat controls the switching relay?
Yeah.
The odd ones.
It controls the when does it go on because it's mounted in the water. This doesn't know anything about the water. It's just a bunch of relays that tells things to come in, fits in the thermostat. But does not know anything about the water, does not know anything about the burner. It has no business with the combustion or heating.
Because the
It just
Aquastat does
tells
a
you
lot
we need
more.
heat in this place, send heat in this place.
Relay does, for
And if
zones.
you notice here, there's a priority switch. That thing, if it's on, this zone will be heated first. After it's satisfied, then it will heat the other ones. Maybe it's a bedroom, maybe it's a living room, so you heat this zone first. Then you'll send the open valve to the other ones. So it gives it priority. Otherwise, if it's off, they're gonna heat up all at the same time. Gives you option.
Do you, where it says isolated end switch, can you explain?
Where?
Does that get wired and then on the Aquastat, you jumper?
At the very end on
Or-
top.
Yeah. This one, I'm not sure what it's doing our functions here, but I'm sure it does have something, I don't know what though. We have not used that. But if you look at the manual, probably it'll tell you how does it function. And this is 20 volts coming from the
Transformer?
transformer. This will tell you that the light, the whole thing is on, which zone is getting heated at that time. Yeah. I'm not sure what is the isolated switch does. Can look it up. Any question about basic wiring of these things? And again, when in doubt, you can always look at the back of the control, and you should have this schematic. And if you don't, then you can always go online and find the PDF for it. Shouldn't be a big deal. However, one of the most important parts for some of those boards is not to wire the 120 and the 24. That's how you burn the board, and you're gonna have to go and buy another one and replace it.
Is the output of the board AC or DC?
To here?
AC.
Yeah.
What do you think?
Oh, I don't know, that's what I'm asking, because it's gonna matter when.
So
you
this one is
wire
giving
it.
you 124 VC, AC, but the controls here are changing to DC.
So we have to
switches.
wire it
Yeah.
correctly for it to work.
Yeah. And this is kind of a similar one. And you will see the In the back, you'll see all the schematic and how it will work. And let's check. Yeah, this is transforming AC to AC, but in the board here, there is a transformer that's going to change the AC to DC. But what you need to know is to wire this properly, the right side. It will come welded so you don't change it. And this is going to be the primary, and this is going to be the secondary. Okay, let's see if they have anything about the end switch here. The end switch here is, it says, if you look at it here, very interesting. So, if I'm reading this correctly, this should go to the TT in the Aquastat relay. If you don't want the Aquastat to control the heats, so I'm going to wire the thermostat. One to here, this is going to go to the TT terminals in the Aquastat. If I don't want the thermostat to have its own circulator. Let's say I want the Aquastat just to deal with the water and no circulator. So I will wire this the TT in the Aquastat and wire the rest of the zones here. And these are thermostat with red and white. We don't need the C's for cooling, so we don't need that. So red and white.
So where's the DC in there? I don't see the DC anywhere. It's all
So
AC.
far, it's all giving you AC, but I'm sure at the back, the control are DC
Oh.
for the logic inside.
Nothing that we need though.
No, no.
Maybe just to turn on the LEDs or something like that.
So, if I don't want to have a zone and circulator going on here, I will take this out and I will connect the TT all the way here, and I will have two zones, two thermostat coming into this board. Question?
Okay, so we can wire two zones with valve or pumps, whatever, like without Aquastat.
Yeah.
Just to use the taco board.
No, you need thermostat.
Why?
How would you know whether if the water
You
is hot
just
or not?
said you can take over thermostat from Aquastat.
Yeah, and the circulator, you put the circulator here, and the thermostat here, and you wire this terminals to the Aquastat here. Otherwise, how would you control the water temperature? This has nothing to do with the water. This has nothing to do with the primary. Make sense?
Mhm.
The primary control the burner. The Aquastat control the water temperature. And this control which zone gets hot water. Good? There's a wiring video. I don't know if it still works.
How to wire circulators to TACO zone valve controls.
I'll give you.
This video was created to help the HVAC professional install and maintain TACO equipment. Please read the on-screen disclaimer before viewing this video. Simple to install, TACO zone valve controls provide reliable and versatile control of residential hydronic systems. You can wire circulators to TACO zone valve controls in a variety of ways to meet the particular needs of your application. In this video, we'll show you 3 scenarios. 1. How to wire a system circulator to the zone valve control. 2. How to wire a system circulator and a domestic hot water or DHW circulator to operate together. 3. How to wire a system circulator and a domestic hot water circulator to operate independently when the priority zone calls for heat. Before getting started, be safe. Turn off the AC power to the circuit you're working on, or better yet, cut AC power to the household. Assemble the tools you'll need. You can download a complete list of tools needed for this project at the link below this video. How to wire a system circulator to the TACO zone valve control. Today we're using a ZVC 404-4. However, this wiring will also work with all ZVC models. Before starting, please note that all the end switches on the ZVC are dry switches, meaning that there is no power until you energize them with voltage. First, connect the 120 volt AC power to the zone valve control ZVC, matching the hot wires, the neutral wires, and the ground wires. Now we will energize the pump end switch. It doesn't matter which terminal you use, but to stay consistent with the drawing on the instruction sheet, we will connect a wire pigtail to the left-hand terminal of the pump end switch. Tighten the terminal screw to secure the pigtail in place. Connect the other end of the pigtail to the hot 120 volt AC line. Next, wire the system circulator to the ZVC. Connect the hot wire from the circulator to the right-hand terminal of the pump end switch and tighten the terminal screw. Connect the neutral wire to the neutral of the incoming 120 volt AC power source. Connect the ground wire.
So this model, in this configuration, will have a pump, big major pump, and 4 zone valve. So once this gets a signal from the Aquastat, it will turn on the main circulator before it turns any of those valves. That's why you have a pump wiring of 120.
Wire to a ground terminal wire and secure the connections with wire nuts. At this point, the 120 volt AC wiring is complete. Now we'll wire the low voltage wiring. Connect the thermostat to the desired zone. Wire the red and white leads from the thermostat to the corresponding red and white terminals at the top of the zone valve control. Here we are using zone 3. Connect the zone valve to the corresponding zone at the bottom of the board. Screw terminals 1 and 2 provide 24 volts to open the valve on a call for heat. If you have a 4-wire zone valve with an end switch, screw terminals 3 and 4 can be used to connect the end switch of the valve. This completes the low voltage wiring of the ZVC. When lit, the green LED indicates that the board is powered. When the thermostat calls for heat, it will cause the corresponding yellow LED indicator to light. The yellow indicator stays lit until the zone is satisfied. When the end switch of the valve closes, it will cause the red LED indicator to glow, indicating that the valve is open and both end switches are closed. When this occurs, the boiler should fire and the circulator will run until the zone is satisfied. If you are using a 2-wire zone valve, then you will need to place a jumper across screw terminals 3 and 4 to cause the red LED to glow and the end switch on the board to close. That completes all the wiring for the system circulator and controls for a single zone. You may now restore power to the circuit. The green LED indicator light will glow, indicating that the power is connected. Note that the green LED should always be on as long as there is power to the board. How to wire a system circulator and a domestic hot water or DHW circulator to operate together.
So you get the idea, but now they're giving all the combination you can do with the same board. And it's good to, when you go and buy the board, to know what you actually want to wire. Do I have a domestic hot water? Do I have a pump? Do I need zone valve, etc., etc.? So the video is there, and also if you go to the TECO website, you find a lot of videos specified for each equipment. They also have good training and manual for each of their equipment. So we'll try that next week and see how it goes. For this week, we'll do just switching relays, and that's it. Be safe, wear goggles, and please try to have really good wiring. Don't try to rush it and put all the wires together. All right.